Good afternoon, everybody. My name is Gaurav. Perfect time to start a webinar. Hopefully, all of you had lunch and are feeling sleepy. Uh, Let me do a quick introduction on myself. I'm a solutions architect here at Amazon, and I specialize in serverless technology. So I like writing code in serverless, creating web apps. So with that in mind, let us discuss what serverless is, what it means to you, what it means for the business that we are in, why serverless, and where do we go from there. So what we are going to start is assuming that you've been a programmer, you've been in technology for long enough. How does serverless come into play, or is it one of those fashionable things that one talks about when they're talking about technology, right? So let's get started very quickly. The points that I'd like to discuss, and what I'd also like to do is leave some time at the end so that we can have an immersive question and answer session and possibly walk you through code and do a few demos if possible. If that sounds like a plan, let's get started. This is what we are going to discuss. Why serverless? What does it mean to be serverless? And if we go through the contract, what is an API? What does API Gateway do? What does it have to offer? Why should we use API Gateway? So I rather love speaking about why on every topic more than the how, because the how, especially when it comes with AWS, is very well documented. Then we'll talk about impedance mismatch of the number of requests coming in and the speed at which we can crunch the responses. So how do you decouple the applications? What are the queuing mechanisms? What are the broadcast mechanisms that we have using SNS, SQS? And then we're going to talk about flows between application where we need to retain state in a stateless applications. And that's going to be done using step functions. We'll discuss X-ray, the one which actually tells you or guides you in finding out where you spend most of your time, how's your application performing in real time. Then we're talking about how to do those developments, because if you're going to do microservices, we are going to go serverless. What is very important is the DevOps side of the things, right? And so we are going to discuss about SAM local. We'll have a small discussion on design patterns, though very frankly, it merits an entire discussion for itself. And and if there's sufficient interest, I'm more than happy to discuss about how the applications are created, how easy it is to create, and what are the best practices. So that would be an advanced level session, maybe for some other day, depending on the interest. So there'll be a poll at the end of it. Feel free to give your valuable inputs, and then we can tune the entire webinar subsequently for geared for your areas of interest. Of course, we'll have a question and answers session. Feel free to throw any serverless questions at me, and I'll try my best to give the most appropriate response, or the places where you could find detailed explanation on any of the topics. With that, let's discuss what it means to be serverless, right? Servers. And for all the 18 odd years that I have been in development, most of the time, for every new project you've spent on is on whether it should be an AMD server or a Linux server, or an Intel server, which operating system should we run on. And then after that, if you're a Java developer, you are again having a plethora of choices. Uh, should I use Tomcat? Should I use JBoss, WebLogic? Uh, Also, what doesn't really go out of your purview, even if you're a developer, is what should be the sizing of the servers? How many do I procure so that we are rightly sized even when the servers retire? And you're also responsible for securing your servers, patching your operating system, making sure the SLAs are met in terms of resilience and uptime. This is typically not the business that your company is in. What you need to deliver typically at the end of the day is a business value to your end customers, which means you write new code, you write better code, you write code to service your business users. Patching operating system makes your server secure but does not add anything to your business. What you do is you actually spend a lot of time to keep the lights on, which means you're looking backward and not forward. You're not innovating on behalf of your customer and for your customer only. What you're also looking at is the operations part of things. How do you maintain service? This really does not add any money or revenue to the bottom line of your company, right? So how can I focus on the things that my customers need without having to focus too much on the infrastructure? So which is why we are discussing serverless. Now, here comes a big surprise. Serverless does not mean that there are no servers. The whole point of having serverless is that you don't have to manage the servers. You focus on what matters to your business, your company, and your customers. So basically, what you do is you write a piece of code and say, "Hey, Amazon, run it for me." If there's no user, none of it will be running for you. There are millions of concurrent users. There'll be million concurrent executions of your pieces of code or function, which is running as a service, right? It is going to be highly available because you don't really have to create a highly available architecture. We've already created it for you, and you don't pay for any time your servers or your functions are not being executed. So this is how it runs, right? Whenever somebody clicks a button, wherever a file is kept in an S3 bucket, this is event driven. Whenever an event occurs, a function is invoked, it executes for whatever number of milliseconds it has to execute, and then it ends. When there's none of it running, you don't pay a dime. And when there are millions running, you don't have to create multiple servers at all. And that's the real benefit. You're focusing on a single threaded model of the execution of your business code. So let's take an example, right? You have a three-tier web application. The UI is rendered on a mobile app, either through a browser or through a custom UI that you've created in the native operating system, like an APK file in an Android operating system. You generally keep your business tier, or at least the consolidation layer, on an app server which is within your data center or on the AWS cloud, right? So you've written a piece of code which is fronted through an API gateway, and the app server hosts that, and the persistence tier is your database. This looks fine. It looks like a three-tier architecture. It looks like a simplistic architecture, and it's been practiced all over. When you're talking about it in terms of implementation, this is how it looks. The content is cached closer to your customer so that the rendering is faster using a CDN. Then for multiple servers that you have across availability zones, you've got an auto scaling cluster connected to a load balancer, which can add or remove web servers depending on the demand. Then the business logic is written into the application servers, and so that you're not dependent on a single one, there's again a private load balancer distributing the load between the application servers. Incidentally, in your persistence tier, if you have a relational database and for its ACID properties, you can write to a master, and there's always a slave sitting in the background getting real-time replicated. All your static content, which is your .html files, CSS, JavaScripts, etc., are stored into S3 bucket and are rendered without servers altogether. This is what a typical three-tier application has been looking like, or at least looks like on the AWS cloud. There will be slightly different implementation if you are hosting your own servers in data centers. You'll also have to take care of the DR part, or the concept of auto scaling doesn't exist. So you'll have to keep all the servers running at all the time. But overall, this is what it looks like. But how does it look like when you're making an application completely serverless, right? This is all there is to it. Mobile apps talk to an API gateway. An API gateway hosts the contract of a RESTful URI. So if you ask for this, and if you are a valid person asking for a piece of information using RESTful, that request is then passed on to the business tier. The business tier is a piece of code for retrieval, processing, storage, etc., is written in AWS Lambda, which is writing a piece of code in a programming language of your choice, but not really spinning it off as a service on a Windows platform or a daemon service that is hosted on a Linux platform, right? You just say, take this code and run it for me. And depending on the number of servers, the number of, number of users, number of Lambda functions would be executed. And then you can go to your other services, including a relational database. You could also now look at newer choices that you have at your fingertips, like a NoSQL database like DynamoDB, right? And now if you look at it, when you run the entire mobile application, there is not a single server that you've spun up. And so you're not really responsible for the operating system, patching, updates, maintaining the server's uptime, etc., etc. If the server fails, it's Amazon's responsibility. It goes into the Amazon's responsibility in the shared security model as well at the patching level. This, when it is implemented, looks like this deployment diagram. Uh, you start again with a DNS hosted on Route 53. CloudFront now caches the static content which is still hosted on S3. S3 is infinite storage at 2.5 cents per GB per month. So that's practically free. Your website could be running, even if it, say, hypothetically runs into 300 MB or 1 GB, doesn't cost you much. The content is cached locally using CloudFront that hosts your website. Every button click on the website, which requires some business action, is now forwarded to API Gateway. API Gateway takes all the API requests, and then for the business translation, business logic that you've written, it's written in Lambda. And the persistence is now done in DynamoDB. In DynamoDB, you can talk at a table level granularity. So you don't really have to worry about schemas or database engines. You can talk at a table level. So you can do your CRUD operations there. Authentication and authorization is then taken care over by Cognito, and the token management is taken care by STS. That's how simple it is in real life. It becomes easy. Now, when I go on to the demo part, we will also see how we've written code. What are the other frameworks that are available to us to make this journey easier for us? Right. So let's proceed. How does a serverless application really function? First is the event. Now we are talking about event-driven architectures. What's an event? A click from the user on the screen. So it's either on the mobile app or on a browser. He clicks the submit button. That's an event. Change in the state of data or change in the state of a resource, which means a put in an S3 bucket could typically invoke a Lambda function. A, a trigger through a CloudWatch alarm. So if you want to react to your infrastructure related events, you could do that, and you could do that using bespoke code. Since now your entire infrastructure is code on AWS, you can actually monitor and react to all those changes in real time using serverless applications. And then you're not restricted to a single programming language. We can use Node.js, Python 2.7 to 3.6, Java 1.8, C Sharp, or Golang as your programming languages. And we are working continuously to add newer languages to its support. So very shortly, if your language is not really listed in it, you already have a lot of documentation on how to induct that language into a Lambda function, but we are going to natively support that as well in the coming times. And then, of course, you can go to a plethora of services, more than 130 services that AWS provides to you. So you could now from here go to a Lex-based chatbot or deep learning or Kinesis streams or whichever, or your storage mechanism to progress onto the application. And so this is how a typical serverless application functions. However, it is not all only about AWS's Lambda and API gateway. There are many players in this execution thing. The compute side we discussed, the business logic which is written in Lambda. Then there's the messaging side to it, which is what we're going to discuss at a later point in the discussion. Then there's the API proxy or the API contract between the caller and callee, which is done through API gateway. Orchestration, how does a chain of events happen and who's responsible for what? And how do you not write thread.sleep in your application to make the same function sleep for a period of time, is what we'll discuss in terms of orchestration. What calls what when, and depending at what stage we are. We can also talk about the storage, analytics, and database part of it, but I have, in the interest of time, not created an extensive deck on that today. But depending on the interest, I will be glad to discuss those topics as well. Of course, what is important is once you start doing these serverless operations, you'll notice that you scale pretty fast. You write and deploy, you go into your CI/CD mode, continuous integration and continuous deployment, so that your changes are fast. What becomes more important is that everything then needs to be automated. You have to invest your time in writing unit tests. You have to spend time in creating your DevOps model so your changes are seamless and don't cause breaks. So we'll discuss that at some amount of detail today. I hope this is what you were expecting from the session today, right? So first thing first, let's discuss the API gateway. What is API gateway? I'll just read it out. It's a fully managed service that makes it easy for developers to create a contract, to publish the contract, to consume the contract, to maintain, monitor, and secure the contract. And this happens at scale. So, and you're charged by scale as well. So if you have no users typically hitting your platform, your spend on the entire serverless ecosystem would be minuscule, if at all. And even at scale, it scales infinitely, theoretically speaking, right? It can absorb the amount of load that you throw at it for your typical spikes. What does API Gateway offer to you? It's the one place where you offer the entire front end, API front end for multiple microservices. So now if you're dealing with, say, let's take a hypothetical example of an office's internal portal. So your HRMS as a microservice or your employee details as a microservice, and all the microservices that you are offering as a part of your organization have a single place where you can see the API contract. What do I need to pass to a particular function to get a typical response? How, what are the number of microservices available within the organization that I can consume? You need, because the developers would be disparate and in separate teams, the single unified contract, the single unified API front end is essential to know what can be consumed. And Amazon API Gateway is exactly that. Uh, then the best way that we can actually mitigate a DDoS attack is by actually absorbing the entire, exhausting the attacker and absorbing the load. So you've got multiple ways of doing this, right? First thing is that an API gateway will have CloudFront sitting in front of it. So there's a content delivery network sitting in front of it. All the static requests are then taken care at the edge itself. So you're not even hitting the API gateway to exhaust it. The second thing that you have under your control is a mechanism for throttling. You can say that the number of concurrent requests that I want a particular set of unsigned users to have is this. And then after that, every additional user that you get gets throttled out of the system. Now, this is important because sometimes what happens is your serverless ecosystem is able to scale infinitely. But if you're using something that is constrained by the hardware infrastructure, say that you've got a relational database which has got a few CPUs, or your code runs very CPU intensive queries or memory intensive queries, you might actually break that down at the end of the day. For that not to happen, you have got throttling at the beginning of the application itself, so your entire ecosystem doesn't get shaken up if there's a DDoS attack. Also, better place to have the entire authentication and authorization control being implemented rather than an API gateway. So every invocation of a contract, an API, gets a challenge through Cognito if you use that, and Lambda functions if you choose to write bespoke code for authentication and authorization. You've got both the options available to you at Amazon's API gateway. So you can now create the contract and authentication and authorization at an API gateway level. And then, of course, provide privileges of who can do what through Cognito. Of course, when you go live, you also want to do a monitoring at real time of how my application or my API is getting consumed. So you can throttle, meter, and monetize your APIs. What I mean by monetize is this. You can have multiple tiers of your users, right? So if you've got a free tier service, you might not want the best level or the highest priority to be available to them. You'd want to throttle them at 5,000 concurrent users in the free tier. But the paying customers need to get a better priority and a better experience. So that is what you can do by creating various stages within your API gateway. So API gateway actually broken down into multiple subcomponents looks like this. Whenever an API call happens, typically it comes through an Amazon CloudFront, the CDN network. The API gateway also caches results if you want to, depending on the TTL. And the cache result can be given out much faster rather than executing code every time you ask for it. Everything is being monitored using CloudWatch, so you can see the graphs in almost real time, though not real time, with sufficient amount of details saying how many of these users were throttled, how many of them received errors, what was the success rate, and concurrency. The execution, of course, can be dependent on various modes of execution. Now, we've got about 50 odd services which directly can talk to an API gateway. Like for an example, you could, if you want to do a create, retrieve, update, delete operation only in DynamoDB, you need not write code for that. Right from the API gateway directly into DynamoDB, you could write code. And these examples are available to you. But a lot of time, what you have to do is write some business logic between a storage layer and your API gateway. And that's where typically an AWS Lambda function comes into play. But you're not just restricted to Lambda. You could now choose EC2 servers if you choose so, or if you want, you could go to Dockerized containers, right? And what happens is your journey is a continuous one. At some point in time, version 1.0 is out in the production, but you're continuously creating newer versions. So you can create a stage at any point in time. So your version 2.0 is not prod, it is in development. And you can create these stages and then expose them through various endpoints. So you can have any stages as per your nomenclature. For example, you could create a dev stage where you're trying out your latest code, uh, and prod, which is exposed to your end customers. You also have something called as canary deployments, where you can actually test out your new code to a small set of users and then gradually make that as the de facto code, so that first you test out, get some amount of confidence that the latest piece of code is working through an API contract, through an API gateway, and then make it production and make available to everyone. What this means is that the impact of failure is reduced. Only a small set of people will get affected if it doesn't work as per it was expected, right? And then once it runs as per your expectation, just call that as prod and everything works. Authorization can be done in multiple ways. One is when there's a business to business API call, you could exchange API keys. And those keys itself act as the authorization between services. That's a service to service level call. The second part you could also do is identity and access management based authorization. And that's for users of which are created within the AWS account that you've created through IAM. But the more popular way of authorization is either using Cognito, which is used for authentication and authorization, or writing your own bespoke code through Lambda. So all these options are available. When it comes to Cognito, you can not only create and maintain your own user pool, because it is a managed user directory by itself. It can provide a hosted UI, so you need not. So what I specialize in UI, because I'm not too great in creating screens, is creating a login screen. Basically, all that it has is a box for username, a box for password, and two hyperlinks. One is submit, and the other is forgot password. But if you don't want to create, there's no brownie points for creating a login screen. All login screens are basically the same, right? All that they have differently is a CSS and a logo of your own company. So Cognito inbuilt provides a hosted UI where you can do your colors, your own white labeling, but it provides the same details out of the box itself. And we'll actually have a demo on that today. Then Cognito also offers federation of credentials to all the popular providers like Google, Facebook, Amazon's thing. And if you are tied to Active Directory, you can use Active Directory Federation Services and SAML for that. And the entire exchange of security tokens happens through the standard token exchange between the service provider and the service consumer. So it uses OAuth 2 for that. So Manage user directory in Cognito provides, as we discussed, login, admin controls for creating new users, sending them SMSs, so on and so forth. Then the hosted UI automatically provides the entire user flow from sign up to confirm, forgot password to two-factor authentication, so on and so forth. And federation is available to you as well. Right. The Cognito, of course, also integrates not just directly through your application, but you could also front it with your credential services in AWS or through a load balancer if you choose to go so. So features that Cognito provides is usage plans to throttle or monetize your API, caching responses. If you need to do a small level of data transformation, so like the case we discussed, right? The API call comes in a complete RESTful way, but for putting data in DynamoDB, you might want to do a few alterations to the entire request. You might want to add the table name, etc. All of that can be done using Velocity template library within API gateway itself. It provides a lot of security features, including DDoS protection, authentication, logging, request validation, and much more. Let's move on to AWS Lambda. What is AWS Lambda? You can run code without having to manage servers and the entire infrastructure. You can scale, you can monitor, and can automate an entire suite of reactions and actions on behalf of you. The great thing about it is that there's no infrastructure to manage. So you write your code and say, run it for me. Second thing is you pay for what you use or what your end users use. So if there's nobody invoking your Lambda function, there's no cost that is being incurred. This is a great way to experiment as well. You write a new piece of code, you run it as a Lambda function. If there's an unexpected amount of success that you've had, no problems. You don't really have to scale for it because it scales infinitely automatically. And then if there are no users, unfortunately, it didn't cost your business anything. A failed experiment can still remain live and wait for the right time for it to catch up. So it is very cost effective and efficient on that part. And then you can bring your own code languages. We do not mandate anything on that. So what are the languages that we support? We go from Node.js's 4.0 to 8, Java 8, Python 2.7, 3.6, C Sharp, which is core, .NET Core 1 and 2, and Golang is something that we introduced. Now it doesn't become too complex when you want to actually, when you're talking about servers, you talk about the amount of CPU, the amount of RAM, the amount of network bandwidth, the amount of available disk space, and so on and so forth. Here, what you do is you've got a single dial, a single knob to control, and that is RAM. And everything is directly proportional to the amount of RAM. And you can change the RAM from 128 MB all the way to 3 GB. And there are people who are doing high performance compute using Lambda itself. And there are frameworks created to that. If you're interested in that, have a look at something called as Pyren on GitHub. It is spelled as Pywren, right? The best way of executing any application is possibly asynchronous, and I'm making a very debatable statement. But both these models are available to you when you're doing Lambda invocation. Synchronous by a direct API call through an API gateway or Lambda invocation through its SDK, or asynchronous where you get the callback object in which you can write your piece of code. Of course, not only can you throttle at the API gateway level, but if you're using Lambda directly, you can throttle at the Lambda level, at a function level as well. And Lambda, as its nature is completely stateless, right? You invoke a function, you pass 2 and 3 to a summation function, it adds those numbers, returns, and it forgets everything. So create your entire application in a stateless manner so you get request response. And if there is any persistence, leave it to the persistence tab. So this is how you would get started. Write your code, zip it up, upload it to Lambda, and then you choose the amount of memory requirements and throttling requirements. And all of that you can get started within minutes. A Lambda function looks like this. In any language that you write, you pass two objects to it. One is the event object, whatever the caller has done. So if you're passing it through an API gateway, the entire API REST event is passed on to the event object, and context in which the Lambda function is running is passed to you. That is the metadata for the function is passed to you in the context object. And then all you have to do is return an object. That's all there is to it. So this is how a function looks in Node.js. And this is the asynchronous code where you get the callback object inside. And that's it. That's a completely running Lambda function, starting from exports.handler all the way to the curly braces. In 3 lines, you're up and running. So what all can generate events which can be handled by Lambda? So on the endpoints, if you're talking about chatbots, even the Amazon Alexa ecosystem works on Lambda, which is where your business logic is written. So everything from an object put in S3, DynamoDB changes. If you're using into if you're into real-time events, Kinesis can trigger event processing through Lambda. Authentication, authorization, bespoke code can be written within Lambda. If you are into stored procedures in relational databases and you're using Aurora, those stored proxies are written in Lambda as well. Endpoints through Alexa API gateway or even the IoT system can be done in Lambda. On the infrastructure side itself, if you want to talk about reacting to changes on the AWS ecosystem, that can be invoked through Lambda, where you can code for the infrastructure changes in Lambda. And then, of course, SQS, SNS, on all the event-driven system, including cron events, which is scheduled events as per time, can be done using that. And then that's all that you do. You don't have to think about how many concurrent executions. You write for a single threaded module. You don't think about how many users there are and there are not for you to do initial sizing. It scales automatically. And you're not, don't even worry about the memory, the RAM, which, where, how of that, nor even the operating system. Don't write something that is dependent on the operating system. Write your code natively, and you're not even bothered about things like OS patching, etc., etc. Right. There's a debatable statement that I actually made is, for you to write good infinitely scalable applications, you need to decouple them so that the number of requests and response, the amount of the speed at which you respond are not dependent on each other. How do you decouple these applications? By using a queuing mechanism. So SQS was one of the first services that AWS launched, and it does queuing. It is a really simple queuing service, as the name goes. So there's a producer producing data at a certain speed and a consumer that is able to consume data at a different speed. So to prevent one speed affecting the other, you use a queue in between, so that failure on one side doesn't really affect the failure on the other side. So that's exactly what the queuing mechanisms do. SNS is a publishing, it's a notification service. So a publisher publishes to a topic. All the listeners to the topic get affected as soon as an event is published to the topic. So you can respond to that topic or the subscription to the topic either by putting the data in a queue in SQS, or sending out an email, an SMS, or writing a bespoke amount of code, which is written, of course, in Lambda. In queue mechanism, what happens is that there is a FIFO or a non-FIFO queue, and you put data in that, and so processor processes it at its own speed, and the creator, the publisher, publishes the data in its own speed. Here, all that you have to be cognizant of is that you are not working on a real-time system. There are other ways of getting to make this work in a real-time system. That's typically using Kinesis as a queue, right? Again, what you have to note in both SQS and SNS is that now you're working using the queue for queue, or a publish subscribe mechanism for itself, and not really bothering about how to set it up, how many servers, how is it highly available or resilient, so on and so forth. That's how easy it is. You create a queue, you start using it using the API and the SDK in your favorite programming language. So which leaves you more time for doing your own business specific code, your business innovation. Let's talk about writing multi-step applications. Not all applications are created by in a request response model. There are a lot of decisions that have to be taken, and those require a workflow. There are at times various actors that are required. How do you do that? That is step functions. Basically, what we have done is create a stateful life cycle in a stateless execution piece of code. So your stateless execution could be typically a Lambda function. Pass me this data and I'll give you a response. But what makes an entire flow to that? You typically require, say, for an internal application like leave management, there's a maker checker check where there are various entities involved. There's certain amount of decision making involved in that, depending on the type of employee there is, right? And all those decisions are not to be hard coded within a Lambda function, or there are wait states which are required, or there is parallelization that is required. You would not do that inside a Lambda function. You would rather create a life cycle, and that life cycle for the execution is done in step functions, right? All that you do is create a JSON file saying that this is my start state, these are my intermediate stage, this is the dependency model, and you create that using a JSON language that we've created. It's called as Amazon States language. The one to your left side is a sample definition of how it looks like. Once you've created the valid JSON, you get a visualization of the entire step function as it is. And then at runtime for every flow, you can see the path that was actually taken and the details on that path. Either it is successful, it is in progress, or it is a failure. You'll get a color-coded graph for that. So this is how easy it is, very frankly, to get started with step functions. The vertices, the arrows, are the step functions. The business logic can be written either in AWS Lambda, or if you prefer, writing it on a server on-prem or an EC2 server, that choice is still yours, right? So what are the types of activities that you can do? One is, of course, go from start to finish in a linear way in a set of sequential steps, so that each of these sequential steps are modules which can be reused across various applications, right? Then there's, of course, branching. There's a decision making Lambda function right after the start, which is the select image converter. And then you've written specific pieces which convert either raw to JPEG or raw to PNG, depending on the choice. So there's branching available. And if you've written flowcharts previously, this is the diamond part of the flowchart that you've written. And of course, you've got parallelization. So if you've got three actions to be done independent of each other, you would rather parallelize for faster execution. So all of that is available to you through JSON. This is how you typically, this is a complete JSON for a hello world example. If you're unsure of how to get started, go on to aws.amazon.com or log on to your account, and there are a lot of blueprints available. One of them is the hello world blueprint that you're seeing on the console. And yeah, of course, you can run one in parallel. So you have a leave management application if you want. If one person applies for a leave and there's an entire workflow to that, one person's step function is executed. Or you could have million such life cycles happening in parallel for a million of your employees at any given point in time. There were 7 steps. I don't want to go into much detail on this one. Task, a choice, a parallel, wait, fail, succeed, or pass. So instead of writing wait states inside your Lambda function, you're paying by the 100 milliseconds count in Lambda, you would write wait states in step functions instead of doing a thread.sleep. That's not a good design pattern. And this is how your execution gets monitored from the console. Of course, all of these logs are available to you as well if you want to use another tool for monitoring. So the choice is yours. So let's go into X-ray. Now that you've written application, you want to see how it behaves at runtime, and that's what X-ray comes. X-ray basically traces requests from the inception stage. If you use an HTTP header, you can put the X-ray header into that, right from that to AWS Lambda, where you find out where the time was spent within the function, and all the way to your persistence tier. So if you want to know what happened to a particular query, it actually takes the entire record traces, and for a specific one, a few of them, you can choose a few as well. If you introduce that into the HTTP header, You can then see how the execution was, where your code actually spent a lot of time. And then you can analyze the issues in your application at runtime for random sampling. So this is an example, right? This is a graph. So a web app made a request to an API gateway, which is where it spent an average of 294 milliseconds. And then what the amount of time that was taken in DynamoDB tables, scorekeep-user, or each of these things, SNS invocations, etc. So you get a split of where your application is actually executing your time, which is very important, especially if you are in a customer-facing environment where your business users' experience depends on how the application performs. So now you have a granular level view of it, and you know where to spend your bulk of your time in optimization without knowing, right? And there you go, you get an S3 trace, and you also get to know where your failures occurred. So now you know that there was a 404 for an S3 put, and that's where you need to focus. That's the thing that failed for your application, and that makes it easier for writing and debugging application. If you have not had a look at X-ray, especially if you're using AWS Lambda, it's just a check in the box, but the results that you get will give you deep insights about the application behavior. So here's the explanation of how the graph behaved, right? The Lambda code that executed spent a total of 1.9 seconds. First, it spent a certain amount of time, which is mentioned as cold start, in starting the Lambda function, which happens when a new container is initialized. And after that, the execution time is then shown to you about 585 milliseconds for the initialization of your function. Then S3 put took 1.8 of your second. Now then you'll have to make sure that you optimize for your customer expectations when you see all these details. But having these details actually helps you write better code at the end of the day. This is how it looks when an async invocation happens. Let me skip this part in the interest of time. Let me actually take you to a squirrel. The squirrel is called a SAM, Serverless Application Model, because when you write code, you typically, when you're talking serverless, you're talking about AWS. Not always do you actually have to go to the cloud when you're developing the application. You can use SAM, which is an abstraction layer on CloudFormation. What it basically does for you is that you can write really simple JSON file or a YAML file to define what your serverless infrastructure is all about, right? And then you can execute that locally by invoking the SAM command line interface, SAM CLI. And then you can test your entire code on your laptop itself using Dockerized container. So you'll have to install Docker on your laptop and then get started with SAM CLI so that you can actually write code, test code locally before you put it on the cloud. And once you do that, what you have at your disposal is three basic resources. Creation of a function where you can now tell the amount of memory that you want to allocate, the timeout, the runtime. Then you have the API. API can be embedded within the Lambda itself. And of course, if you want to create tables, that is available to you as well. So a simple API just looks like this. You have one in front of you. All that you say is that this is my serverless function. I've written it in the method that gets invoked is the index.handler. The code is written in Node.js 4.3, and this is where I've kept the folder, the code, which is local underscore folder. When does it get invoked? On any path called a slash, it gets invoked. So, and then within the API, you can now tell the stage, whether it is the dev stage, UAT stage, etc. You'll also provide the roles and privileges for the Lambda function to execute and what it can do. So that's pretty much a SAM in short. It's a very, very interesting topic. If you're going microservices, I strongly urge you to look at SAM. Now, there are a few design patterns that you can talk about. This is the service proxy pattern. I'll hurry through these a bit because these are advanced level topics. I would rather spend a lot of time with you on Q&A. And I'll also show you a quick demo on how these can be done. So I'll quickly scan through these. This is the service proxy where API gateway fronts a lot of backend services, provides a unified contract for all the services that you provide to your customers uh, in that. Then this is the real-time data processing where data at real time from multiple sources like IoT devices, a lot of servers is ingested at scale through Kinesis Firehose. The data is then given into Amazon Kinesis Analytics or an AWS Lambda function, where you make sense of the real-time streaming data in real time to provide responses. The data is then either persisted in a petabyte scale warehouse like Redshift or a NoSQL database like DynamoDB. Or if you want to persist it over a longer period of time to make longer term decisions of the data usage patterns, you'd shove it into S3 by creating a data lake. Then your data scientists come and analyze the data without really creating an entire Hadoop ecosystem by writing queries on the fly and getting them executed using tools like Athena. And a lot of real-time data processing requests are happening today, are going live because the whole barriers of cost and the difficulty of executing the entire infrastructure is going away today. This is the IoT ecosystem. If you've used AWS IoT, or if you're in that business, a lot of things in IoT send data over a low latency platform like MQTT, and then you subscribe to the topic and you react to everything that happens depend on the server side using AWS IoT. You write rules for actually invoking which process to get invoked depending on the condition. And you can write your bespoke code either in Lambda, or you can react to events using SQS and SNS. Uh, for iRobot, they're actually adding millions of users, and they're doing an automated Roombas, which is a vacuum cleaner, robotic vacuum cleaner. And this is their architecture diagram about how does a new robot get registered into their ecosystem, how does it send data in real time, how does it learn over a period of time. If you have not really watched the videos, I'd strongly recommend for you to go and watch those videos. They make excellent case studies. So let me very quickly now go on to a demo to explain how this all works in the real time. Just give me a second. Screen. There you are. I hope you can see my screen here. Okay, this is my browser. So what I've created is a very simple web application. Now, all that it does, it creates employees, it gets employees, you can update and edit an employee. The interesting thing about this is that the entire application is completely serverless. This website that you are seeing is hosted on S3. It contains I've created it using vue.js. And now, if you need to do any of these operations, you need to log in. So as soon as I press the login button, this is the UI that I have created automatically without writing a single piece of code using Cognito. I put in my credentials. This entire user management is done using Cognito. I press in, and I'm into the application as Gaurav. So here now, instead of saying the login button, I see logger. Once I press this button, it gives a call to an API gateway, which calls a Lambda function, fetches all the details from a DynamoDB table. And then, of course, you can go and create, sorry, I have not created validations on this one. Random user, and there you go, create. There you go, random user got created. You can now go and delete this. And that's how simple it is. The application can be really created using code which is as small as this. This is all there is to it. a single line app.py file. And now I'm saying that if the employee, so if you want to get all the employees, call the URI employees on the API gateway. This is created using a framework called as Chalice. It gets you started on the entire serverless ecosystem and gives you a Flask-like behavior if you are into Python. And you get started within 20 minutes on the entire ecosystem of serverless. It creates APIs for you, it creates Lambda functions for you, and deploys them as well. You can test this locally as well using SAM CLI. So that's all there is to it. If there's a delete method that is called on a particular phone number, the user is deleted. If there is a put request, you then first find the right user and then you update the user. A post creates a new user. And this is a listing of all the users. Once you've created this entire server side of code, which is 78, yes, 79 lines long, you're up and running without writing servers, without writing operating system specific things, and you just deploy from the command line that Chalice provides. Chalice is an encapsulation in Python. Similarly, there is serverless for Node.js, there is serverless for Java, uh, and all that. And then on top of it, if you are into any specific UI, Angular, React, etc., use the package called as Amplify to create your client-side code, and all that you need is created. So this is all there is in the UI, frankly, which I've created using Vue.js. And your applications get up and running within no time whatsoever. Right? So from here, where I'd like to go is to the question and answer session. If you are interested in specifics of this, I'm more than happy to take that in the question and answers as well. So let's proceed to the last part, which is Q&A. Any questions? Feel free to actually put it in the questions tab of your webinar meeting. Right? In the meanwhile, thanks a lot for joining. I hope you've enjoyed the show. Your feedback is very valuable to us. Keep me in the know. So yeah, for the next 8 to 10